I was going through questions about number sequences yesterday with a student. When we study number sequences at GCSE, we usually look for the difference between two numbers in the sequence. And quite often, if that number's the same every time, then we know that it's a linear sequence. And if we do two rows of the same sort of thing, we can use that to figure out if it's a quadratic sequence. But sometimes in exam papers, you're asked to look at sequences. There's one question I've seen before where you have to match up sequences on the left to the names on the right, and sometimes those will be prime numbers, square numbers, odd numbers, cube numbers. Fibonacci, I forgot that one yesterday. I actually need to do Fibonacci with that student. Yeah, we were going through this problem. We were looking at the difference between prime numbers, and it suddenly sort of struck me that, well, first of all, I was thinking, would this make a good random number generator? Because prime numbers are sort of randomly distributed. There's no clear pattern. And then the next thing was, actually, no, it doesn't make a good random number generator because so many of them are twos. In the first few prime numbers, the difference between a lot of them is 2. Well, you can't have two prime numbers next to each other. So the closest they can be is there has to be a number in between. 2 and 3. 2 and 3 are next to each other, but 2 is the only even prime number. So the rest of them are odd. So they have to have at least one even number between them. That's right, isn't it? And then that led me to thinking about something called the Twin Primes Conjecture, which just basically says that on that, if you keep going, the primes never end. And I'll probably go through on this video, a nice proof by Euclid that the primes never end. So the primes never end. There's an infinite supply of prime numbers. And so somebody had the bright idea, I wonder if there's an infinite number of twin primes. And they still haven't been able to prove that. They haven't proved it. It would be a good topic for a computer program just to experiment with. You can't solve a problem like this with a computer. Well, the sort of program I have in mind would be you'd look at the first million or the first billion and then just for fun find the highest twin prime. That's the sort of program I'd be thinking about. But obviously you can't use a program like that to test all prime numbers. You can't do it. So you have to prove it some other way. So here's a good example of a proof. Euclid proved that there's an infinite number of primes using reductio ad absurdum, which is where you assume something's true and then prove that it's impossible. So let's imagine that you're not very good with prime numbers and you think that maybe these 3 or 4 are the only prime numbers. So say you've got 2, 3, and 5. All you do, and obviously this is just an example with a very small number, but imagine if you took all the prime numbers that you think, that's it, there are no prime numbers beyond this point, and you multiplied them all together and add 1. So if we use 2, 3, and 5 as examples, you multiply 2, 3, and 5 together, which gives you 30. And then you add 1, and that gives you 31. So the thing about 31 is it's right next to a number that has factors 2, 3, and 5. And because you've just added 1, it's not a multiple of 2, it's not a multiple of 3, it's not a multiple of 5. If you added 2, it would be a multiple of 2. If you added 3, it would be a multiple of 3. And if you added 5, it would be a multiple of 5. But 31, because you've added just 1, is not a multiple of 2, 3, or 5. So if 31 turned out to be a composite number, which it isn't, if it turned out not to be prime, it would have to have prime factors other than 2, 3, or 5. So that would introduce a new prime number. And obviously, if it isn't composite, well, it's a new prime number. You've got these 3 numbers, 2, 3, and 5. You think that they're all the prime numbers that exist. You multiply them together and add 1. And that would lead to 2 scenarios potentially. Either it's prime or it's not prime. If it's prime, there's a new prime number. If it's not prime, it contains a new prime number, so your list wasn't exhaustive. And you can do that with as many primes as you want, and you'll always find there's another prime number that wasn't in the list. And that is how Euclid proved that there's an infinite number of primes.
Holy shit, fuckballs. Whoa, girl, fuck, wow, oh my god.